Welcome to a short video on why we used to do it that way. Today I'm talking about why we used to develop software using one particular method, why it made sense then, and why perhaps it doesn't make sense now. Why am I talking about this today? Because at the moment there's a lot of pushback against agile methods of software delivery. So perhaps a bit of history can put things into perspective. The first electronic digital computers were built during the 1940s, mainly for military use and then for scientific calculations. Using computers to solve business problems started back in the 1950s with comparatively simple batch programs that could manage payroll calculations or help with stock management. Lyons Corner Houses were a chain of cafes on every British high street for most of the 20th century, and the scale of their operations led them to develop one of the first commercial computers and probably the first ever enterprise resource management system, and that was to ensure the smooth flow of stock to their cafes. Data was collected by hand and then transferred to punch tape. The punch tape was fed into the computer, which then printed out detailed lists of what stock would be needed by each store and when. Humans did not interact with these programs. You put some data in and then waited for the results to come out. As computers increased in power through the 1960s and 70s, they became capable of handling multiple operations simultaneously, and middleware like IBM Kix enabled more sophisticated programs that supported terminals and were interactive, giving teams of operators the ability to conduct different operations at the same time. These more complex systems were specified by business analysts, then designed by computer analysts, then coded by teams of programmers, and finally tested by the QA department. The computers were still big machines filling whole rooms. Time on them was expensive and access was limited. For example, in the 1970s, programmers writing business applications did not type their code directly into the computer. They wrote it out on programming sheets in longhand. Then secretarial staff would use machines to transcribe those sheets onto punch cards. A typical 1970s mainframe has less main memory than a modern smartwatch and is about 10,000 times slower, so it hasn't got time to sit around while a programmer types in code one character at a time. The whole program is read in from punch cards, and the mainframe tries to compile it ready for execution. If there's an error, the programmer gets a printout and has to make corrections and go through the whole process again. So access to compute resource, whether it was for compilation, debugging or testing, had to be carefully allocated. Now in this world, it really makes sense to design everything up front and then plan when resources will be available. Project managers had to schedule the different phases of the project carefully, allocate computer resources, and try to keep everything on track and on time. And no one back then really expected software to be delightful or easy to use. The interface was just a set of text screens with fields where operators would enter their query. You either hit enter to move to the next screen, or you selected an operation from a menu. Operators were trained to use the applications. There was no expectation that an application would be so intuitive that anyone could just start using it. Waterfall software development was the best way to develop software 40 to 50 years ago. But two things have changed since then. First, compute resource is now cheap and easily available. Programmers input their code directly into a computer and can see it execute almost straight away. This makes it very easy to iterate and refine. Second, everybody is an end user. You can't assume the user of your application has received extensive training on how to use it. This means that for most applications, usability is a key non-functional requirement. And it's very hard, if not impossible, to build usable software if you design it all ahead of the first time a human tries to use it. The removal of the constraints on compute resource is what makes agile development possible. And the need to make software that's usable, intuitive, and even delightful is what makes agile development important. But often prescriptive agile methodologies are imposed on teams as just a different way of doing project management, and the real benefits are not realised. So why is there this pushback now against agile development? If it's hard to develop software that's usable and delightful using waterfall processes, what's driving the upsurge in nostalgia for this older practice? The reality is that a lot of development shops out there say they are doing agile, when what they're really doing is imposing a rigid form of Scrum on their development teams. At its core, agile development is about accommodating change and enabling progress to be delivered in small but visible increments. Accommodating change makes it easier to incorporate improvements based on user feedback or changes in the business proposition. Continuous delivery of small increments satisfies the business stakeholders that progress is being made. But you don't get those benefits by creating a set of rigid requirements, setting a fixed end date, and then forcing your dev team to create your deliverables over 8 4-week sprints. Fast delivery of high quality software requires a set of interlocking disciplines and practices. And agile practice does require discipline. Everyone on the team needs to have a clear understanding of the problem you're trying to solve, how solving it will bring value to the business, and how to know whether or not you are succeeding in the project goals. So let me know what you think about this in the comments below. And as for the rest of those interlocking disciplines and practices, that's a subject for another video. I'm Paul Kelly with the Modern Curiosity Shop, and I look forward to seeing you next time.